Hi, good
Hello.
morning all. This is Vishal Singhal from Selstrat, your host for today. So we have Miss Namita Mahindru. She's an independent AI education evangelist. So she will be taking us through the use of AI and deep learning in education. So this session is being recorded and will be made live on our Selstrat YouTube channel. I'll share the link for in a few minutes. And I suggest you ask as many questions as you have as they come to your mind. She's an expert in this area in education. So over to you, ma'am.
Okay. Thank you, Vivek. Thank you, Vishal and Vivek both. And I'm Namita Mahindru, as Vishal has already introduced me. I'm an AI education evangelist. Actually, I have the e-learning experience since I started my journey, my professional journey in 1995. I did my MCA in 1994, and then I joined IGNOU. As you know, IGNOU is a distance learning university. So I got the exposure of distance learning there itself in the year 1995. In distance learning, I gave the lectures through television, through those were broadcasted through radio and so on. So I had this distance learning experience since the very beginning. Then in 1997, when internet was just introduced, we were the lucky ones who had the opportunity to use the internet. We had the dial-up connection that time, and I remember we had the opportunity to conduct rather the first web conference through IGNOU, and that was through dial-up connection. In that, the participants were not present at one place. They were all from different areas, different regions, and they could use that web conference in that time in 1997. Then at IGNOU itself, I gave online lectures, made the material, content material, and that time there was a program called CWDM, that was a website design program, which was conducted online at the website. That program, I not only created the content, rather I did online mentoring that time in 1997-98. It was so many years long. Now, after that, I did had an e-learning experience in companies like Edexcel. This is a UK-based company. I had also been to UK for this work, and then I had the online experience with the NIIT Varsity. In that, I basically taught the students of the US University through NIIT. So I have been into this e-learning area since the very beginning. Now, that time, online education was a far-fetched idea. You could never think of that you will have online education like you are having these days. Now, these days, because of COVID-19, it has become a need of the hour. Now, what if artificial intelligence is also clubbed with this online learning? Artificial intelligence will work as a catalyst here in online learning. Now, how it will be done? This will be discussed here in this session. So, moving on to the session now. If you have any questions, any this thing, you may keep texting here. I'll be very happy to answer those.
And you are
Artificial,
inaudible.
yeah.
Okay.
Hello, are you able to
Yeah, go
listen
ahead.
to me now?
Go ahead.
Yeah. Artificial intelligence in education. If I ask you to define what is artificial intelligence, you means any layman, he would answer in one word, robot. And this is probably the right answer also, because the robot is an intelligent agent that needs to have certain features like natural language processing, knowledge processing, not planning, perception, decision making. Now, artificial intelligence has is you can find artificial intelligence applications in many different areas nowadays. You can find its application in areas like entertainment, finance, healthcare, etc. Here, I would discuss artificial applications in education. Now, in every area, if you look at, the use of artificial intelligence has made our lives more comfortable and fast. Why? Because it has the ability to solve the complex problems in a very efficient manner. Now, how this artificial intelligence can be used in education? In education industry, it has basically helped in it basically focuses on cognitive processes like perception, reasoning, learning, problem solving. So basically now how it has helped in this, if you look at the present education scenario, you will find there is a lot of gap between the way we teach and the way we learn. You will find that there is only one system through which every child in the classroom is taught. But each of the students may have their own learning styles, their own learning preferences. So basically, you are not looking at those learning styles and those learning preferences. So what happens? There are very few students who actually enjoy the learning. There may be a group of students in the classroom who find it very difficult to perceive things. It is very difficult for them to understand. And there may be other group of students who find it very disinteresting. So there is a very small group who actually enjoy the education, enjoy the learning. That means one fits all system doesn't work here, and you have to have a personalized learning in that case. Now, personalized learning, if you look at, it could be very difficult because you cannot afford to have personalized learning for every student in the class. It involves a lot of time, labor, effort, and money. So what if this personalized learning is made possible using artificial intelligence? Next, just a moment. Hello, I'm just having problem in moving the slides. Let me just do it.
Try the arrow keys on the keyboard, yeah.
Okay. Education, I think, is going to be the killer app for deep learning. This is a quote given by Terry Sejonsky from the SAC Institute, California. Then there is another quote given by Tom Michel defining what is artificial intelligence. Artificial intelligence is a computer program. A computer program is said to learn from experience E with respect to some class of task T and performance measure P if its performance at task in T as measured by P improves with experience E. So you have T, P, and E here. T is the task, P is the performance, and E is the experience. So task is performed, its experience is seen, and its performance is measured here. So this is another kind of definition of given by Tom Michel in his book on machine learning. Now, coming over to the objectives of this session. In this session, we will introduce artificial intelligence, introduce machine learning, introduce deep learning, and use AI, ML, and DL in education. Now, all these terms, AI, ML, and DL, are correlated to each other. Artificial is the bigger picture. Then you have machine learning. Then you have deep learning. That means deep learning is a subset of machine learning, and machine learning is a subset of artificial intelligence. And the bigger part is artificial intelligence here. Now, what is artificial intelligence? Also called machine intelligence. That means if there is any task which you do through a machine, it would seem as if it is done by a human being. It is called artificial intelligence. Now, this artificial intelligence could be done either through a software or through a robot. That means you are using a hardware or a software. So, AI is any task performed by a piece of software or a machine that if a human carried out the same activity, we would say the human had applied intelligence to accomplish the task. That means AI is the ability of a machine to perform tasks that are commonly performed by intelligent beings. That means simulation of human intelligence. Now, coming over to machine learning, what is machine learning? Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. Now, data is an important entity in machine learning. The more and more data you provide to the machine, the more processing is done in the machine. It looks for patterns within the data and predicts the new data based on those patterns. That means it will apply that pattern. It is something like the learning of a small child. Like initially, when you show pictures of fruits like cherry, apple, and orange to a small child at a very small age, it is very difficult for him to distinguish between these foods. But as he grows up, he learns from his parents, his teachers, his surroundings. That means he gathers the information from his surroundings and gets to know a lot of information, and it is easy for him to distinguish between the various foods and other things. Similar to that is, as and when you provide more and more data to the machine will learn from that data, from the patterns within the data, and predict the new output. Machine learning algorithms use statistics to find patterns in massive amounts of data. Data could be anything like numbers, words, images, clicks, etc. It can be digitally stored and can be fed into an ML algorithm. That means data need not be numbers or letters or so on. Those could be anything like images, clicks, whatever you find on the social media is the data for the machine learning. Machine learning is widely used in recommendation systems like Netflix, YouTube, Spotify, Google, Facebook, Twitter, etc. It's used in voice assistants like Siri, Alexa also. Now, these things are very common nowadays among, among all of us. These are not new things. What happens like, what does this recommendation system do is like if I'm watching a romantic movie on Netflix, next time he looks at my preference of choice and it recommends me those particular kind of movies to me. It recommends me. Similarly, YouTube also, when you're listening to some spiritual songs or romantic songs, it will recommend the similar kind of things to me. So all the above mentioned systems collect data from you, feed to an ML algorithm, and make a guess of what you may want next. That means it works as find the pattern and apply the pattern. Now, types of machine learning. What are the types of machine learning? You have supervised learning, unsupervised learning, and reinforcement learning. Under, as the name suggests, it's very clear from the name supervised learning. Supervised means there is always a teacher who is supervising. In unsupervised learning, there is no teacher, the data learns on its own. And under reinforcement, reinforcement means to repeat a task. So there is an agent that interacts with the environment to produce an action. If the action is positive, the reward will be big. If the action is negative, the reward will be negative. So depending upon the reward, it will repeat the action. This is in the pictorial representation. You have a teacher here in the supervised learning. There is no teacher in the unsupervised learning, and there is an agent here which interacts with the environment to perform the action. In supervised learning, both input and the output data are labeled. Both input and output are labeled. That means the training data here is the teacher here. Under unsupervised learning, there is no labeling of the data. And data looks for patterns. The model basically here looks for patterns within the data. And looking at the pattern, finding the pattern, it will apply that pattern to get the output. Difference between supervised. So you have the machine is using the label data here. So the teacher here is telling the students that this particular thing looks like a ship, this particular thing looks like a, I mean, whatever it is. And in the unsupervised learning, the child is learning on its own from the previous notebooks, from the previous data. In reinforcement learning, the agent interacts with the environment to produce actions and discovers errors or rewards. So it will try to maximize its rewards and minimize its errors. Supervised learning, computer is presented with example inputs and the desired outputs. The goal is to learn a general rule that maps inputs to outputs. Under unsupervised learning, they take a set of data that contains only inputs, find a structure in the data like grouping, clustering of data points. The algorithms learn from test data that has not been classified or categorized. So you have the test data here from which the algorithm is learning. And in the supervised learning, you have the training set from which the algorithm is learning. In reinforcement, it's provided with the dynamic environment in which it must perform a certain goal, like driving a vehicle. Nowadays, you find in driverless cars, it is using reinforcement learning. In games like AlphaGo, chess, etc., you use reinforcement learning. Now, what kind of problems are solved under supervised, unsupervised, and reinforcement learning? In reinforcement learning, you can solve regression kind of problems. Regression kind of problems are those which have a continuous value. In these kind of problems, you have continuous value since the last so many, and looking at the last data, you will find the values are continuous. That means an example of this could be house prices. The house price, looking at the house prices of the previous years, you could predict the house prices of the present year. In an academic scenario, you can take the example of the fee structure. Looking at the fee structure of, let's say, class 11 of the last few years, you could predict the, what would be the fee structure of the present year. That means the increase or decrease, looking at the increase or decrease in the past few years, you could predict the fee structure of the present year. Then you have classification problems. In classification, as the name suggests, you would classify into groups. When you're classifying into groups, you are given predetermined characteristics. Let me explain this through an example. Let's say you are classifying your classroom into two groups, at risk and not at risk. Under at risk, let's say you will group students who have scored less than 40% marks, and not at risk, under not at risk category, you will group students who have got above 40% marks. So already there are two characteristics on which the groups are identified, groups in which the data can be classified. Then you have, when you're coming over to unsupervised learning, you have association problems and you have clustering problems. You can solve association kind of problems and clustering kind of problems. Under association kind of problems, basically you will look for data that frequently co-occur or are associated to each other in some or the other way. An example of this could be, let's say, if somebody purchases a maths notebook, it is very likely that he will purchase a graph notebook and a calculator. So a maths notebook, graph notebook, calculator, all these things are associated to each other. So these kind of problems are solved in association kind of things, unsupervised learning. Then you have clustering. If you can see from the graphical notation here, the data is grouped under, uh, basically classified under two groups. It is similar to classification, but the only difference is that this classification falls under supervised learning and clustering falls under unsupervised learning. Here we do not given any predetermined characteristics to the data, and what happens, an example of this could be, uh, let's say you give an aptitude test to the students in 11th class from all the sections, from science, from commerce, from arts. If you ask them to attempt the aptitude test, and later on you find there are some students who are good at maths, computers, English. Now you will group them in one cluster, irrespective of the fact that they belong to arts, science, or maths. That means in that cluster, only those students are grouped together which have good aptitude, better aptitude for these particular subjects. But they may belong to different streams. So the data points in one cluster are very closely associated to each other, but the data points in one cluster are very different from the data points in the other cluster. Next, coming over to reinforcement learning. Here, as you can see, there is an agent here which interacts with the environment to produce an action. If the action is positive, the reward will be good. If the action is negative, the reward will be negative. So the agent will try to get the maximum rewards, and it will repeat the positive actions. It is used in games like AlphaGo, chess, etc. Now, this was about machine learning. Now let me tell you something about deep learning. Deep learning is a subset of machine learning where artificial neural networks and algorithms inspired by human brain learn from large amounts of data. When you have large amounts of data, you apply deep learning. When the data is too much, too big, then you apply deep learning. The processing inside of a human brain is analogous to how data is processed in deep learning. Like in a human brain, you have neurons which send signals to other neurons. Like when you get a sensor input from your this thing in your nervous system, one neuron sends the signal to the other neuron, then it goes to the other neuron, and so on. So in this way, the information gets processed within your mind. Similar to that is the working of the artificial neural networks in which the data is processed for deep learning. Deep, as the name suggests, there are multiple layers of processing here. So accuracy of the data, accuracy of the model will also increase. The name deep learning is because the neural networks have various deep layers that enable learning. They attempt to draw conclusions as humans would by continuously analyzing data with the given logical structure. What are neural networks now? Neural networks form the base of deep learning. This is a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Human information processing takes place through the interaction of billions of neurons connected to each other, each sending signals to other neurons. Now, here is the pictorial representation. As I told you in my first slide that artificial intelligence is the bigger picture, then you have machine learning, which is a subset of artificial intelligence. Then you have deep learning, which is a subset of machine learning. And within the deep learning, you have neural networks, which form the basis of deep learning. And the working of this neural networks is similar to the working of the human brain, where the information is processed. So you have input layer here, you have the output layer here, and in between are the hidden layers where the processing is done. And the more the number of hidden layers, the better output it will be. So neural networks take in data, train themselves to recognize patterns within this data and predict the output for a new set of similar data. Let's take the example of identifying an image. We have taken an example of a circle of 28 by 28 pixels here. Now each pixel of this image is fed as input to the neurons of the first layer, which is then fed as input to the neurons of the second layer, and so on. Now the input of this first layer and the input of the second layer are connected. Neurons of the first layer and the neurons of the second layer are connected to each other through channels. Now there is a weight associated with each of these channels, and the weight determines the strength of the connection of the neurons. The more the weight, the better output it will be. And we have the activation function here. Activation function decides which particular neuron will get activated or not, whether a particular neuron will get activated or not. So what happens? Input multiplied by the weight, inputs multiplied by the weights, all the inputs x1 into 0.8, x2 into 0.2, all these inputs multiplied with their corresponding weights, plus a bias value that is added to each. This is a constant value that is added to each neuron. This gives the activation function, and the result of this activation function decides whether a particular neuron will get activated or not. In this way, we are able to figure out here that this is a circle, because circle has the activation function of this circle here is maximum 0.9, and this is just a probability with errors in it which can be removed. Example of neural networks are different. Now, this is in written form what I have told. Neural networks are made up of layers of neurons, the core processing units of the network. First, we have the input layer, which receives the input. The output layer predicts the final output. In between exists the hidden layers, which perform most of the computations required by computations are those activation functions. Now, this is in the written form what I have explained. What are the applications of artificial neural networks? Artificial neural networks, as I told, forms the basis of deep learning. We have facial recognition, forecasting weather, and music composition. These are three applications I have defined, but there are other number of applications also. Now, face recognition. Nowadays in smartphones, you can use the password as your face image. Now it asks for the image of your face, it recognizes your face, and this could be used as a password. If somebody else looks at your phone, it will not let you enter in, it will not let you access that phone. So facial recognition applications can be found in a number of other things also. We'll discuss in the next slides. Then you have forecasting weather. Looking at the pattern of the previous year's data, looking at the pattern of the weather of the previous years, you could forecast what would be the weather in the current year at a particular time of the year. Then you have music composition. Like if you input some music tones to the algorithm, it has the ability to compose a music of its own also. Facial recognition application can be found in sites like Ole. It analyzes your skin. It asks for your photograph of the image of your face first. That it analyzes your skin. Analyzes means it tells you that this particular area is your best area of the skin. This particular area needs improvement, and it can also analyze the age of the skin. It's showing here the skin age is 34, and this area needs improvement. You may have dark circles here, you may have wrinkles under your eyes, so it will tell you that you need to improve on this area. And unveiling your skin age, it gives a personalized skincare routine. It will tell you that you have to apply dark circle cream under your eyes for the dark circles, For your wrinkles, it will prescribe you some other cream. So this is how facial recognition is used in at this website. This is one example of it. In the further slides, I will also explain how facial recognition is used in the education field. Forecasting, like I told you, you can forecast the weather in the current year depending upon the data of the weather in the previous years. Music composition, you are given musical tones as the input to the neural networks. It has the ability to compose its own music. Then you have coming over to deep learning applications in education. Now, best learning is when you have one-on-one interaction with the tutor. In that case, the teacher will can get to know what are the strengths, what are the weaknesses, what are the strengths, what are the weaknesses of the student, and the teacher can basically converse better in telling the student that you need to cover these particular areas to come up to a particular level of learning. So the teacher can basically teach the student about what is to be learned. He can look at the learning styles of the students and also the preference of the students, like learning preferences, what he likes and what he doesn't. So looking at that, it can be done. This is called personalized learning that you can have in your tuitions and all. You have one-on-one tuitions. In that case, the tutor basically analyzes what are your weak areas, what are your strengths, and what you need to cover. So the teacher there, what happens, the physical tutor does what? It gives you a list of resources for you to cover those. Now, what if this is made possible using artificial intelligence? This is called personalized learning. We'll talk about this in here in deep learning. Historical trends in deep learning. Deep learning has had a long and rich history, but has gone by many names, reflecting different philosophical viewpoints and has waxed and waned in popularity. Deep learning has become more useful as the amount of available training data has increased. Deep learning models have grown in size over time as computer infrastructure, both hardware and software for deep learning, have improved. Deep learning has solved increasingly complicated applications with increasing accuracy over time. Best education is when you have one-on-one instruction with the adult who's really good educator, and the child who the adult understands can get help through mental blocks and so forth. But that's very expensive, very labor intensive. Deep learning has been successful at the machine-human interface. That means deep learning algorithms have been using this speech, vision, language to overcome these things to get the personalized learning. The student can interact with software application platforms and humanoid robot tutors. That means you have AI applications in the software form, or you could have in the humanoid robot form, where there is somebody you can talk to. It will be much more natural and it will make it more fun to have someone that you can talk to rather than a static computer. So even in the static computer also, if you have AI applications there, you can have chatbots. These chatbots are what? They are AI powered chatbots, and basically whatever data you feed in when the this thing when you create the chatbot, you can feed in a lot of things there. They frequently asked questions by the students. When you feed in the frequently asked questions in the chatbots, if the student asks those particular questions, that can be answered easily by the chatbots. Then you have smart content, intelligent tutoring systems, and virtual facilitators and learning environments. Now, all these three are deep learning applications. Smart content is what? Like, uh, from a this thing point of view, if I tell you that when a student has to prepare for an exam, what he does when he's reading the textbook for the first time or preparing for the exam, what he does, he highlights the important points, makes true and false questions, makes summaries, and leaves the unimportant part. So looking at the pattern of the last year's question papers, he gets to know what are the important points he has to focus on. So he creates summaries, he highlights those, he focuses more on that and leaves the unimportant part. Now, what if this can be done by a software? So smart content does all this work for you. It basically condenses your textbooks so that you can concentrate only on the important points and create summaries and creates true false questions for you to prepare for the exams. Then comes intelligent tutoring systems. These are personalized electronic tutoring customized to the learning styles and preferences of the pupil. Like I have told you earlier, you have in software forms and in robot forms also. Then you have virtual facilitators and learning environments. Now these virtual facilitators are similar to personalized learning. Only thing is these are facilitators and these facilitators can address a number of students also together. Like a teacher addresses to many students in a class, you have virtual facilitators and learning environments. Automated grading. Now here I'll talk about the online assessment that has been made possible using GradeCam. Now GradeCam is one of the applications here. I'll talk about this. What it does is literally reads your student's handwriting. Not only that, students can then score the answer based on the answer keys the teacher has provided. It can accurately read numerals, dashes, periods, slashes, and fractions. It will tell you whether the answer is correct or not, and it will grade into a grade book. Like you could grade in a report card as a teacher. It is basically for the educator. Now, what it does is the students are asked to write the answer sheets, attend the question paper on the answer sheets. They are asked to scan those answer sheets, and those scanned answer sheets are fed as input to this machine. The machine looks for the answer keys provided by the teacher, and if the answers are matched with the answer keys provided by the teacher, it will mark them as correct. And if there is something that the machine doesn't understand, it is difficult for it to interpret. In that case, it will mark as review to the teacher. The teacher would physically mark them, and that particular marked answer sheet will again be scanned and put as input to the machine. So the next time, if the same kind of thing appears again, the data has already been provided there to the machine. That means every time the data gets processed, the machine algorithm gets updated. So in this way it is done, and not only this, it will create a report card, like the teacher creates a report card. So it will provide grades of every question in the grade book, and it will show that the student needs to work more on this particular area. This is his strength area, this is his weakness, and he needs to work further on this. So basically, again, it is kind of giving personalized learning to the student. Personal assistant for lifelong learning. Now, this is the website address. This is another address of the website. This link here is giving a link to the website that is providing personalized learning. So PAL3 help learners navigate learning resources through an embodied pedagogical agent that acts as a guide, a persistent learning record to track what students have done, their level of mastery, what they need to achieve, a library of educational resources that can include customized intelligent tutoring systems as well as traditional educational materials such as web pages. That means it gives a curated list of resources to the student. A recommendation system that suggests library resources for a student based on the learning record. This is another website for personalized learning, RIID. It is a Korean startup, provides AI-based education, uses reinforcement algorithms, learn on its own to reach a specified goal, maximizes the probability of a student achieving a target score in a given time constraint, and it can teach students better in lesser time. This is another example of personalized learning, Acutus, which is funded by DARPA. It is an AI-based tutor that trains in months rather than years. That means it's faster. These are feedback of the website. Then coming over to facial recognition applications. Now, facial recognition application can be used in education field for class attendance and for proctored exams. Now, how it is done for class attendance? What happens normally in a class? The teacher is doing the administrative work of taking attendance in the class. She's asking one name after the other and looking for writing present absent on the register. Now there may be possibility of proxies also and manual errors in this case. Now what if all these things are eliminated using a facial recognition application? So how it is done? Now the computer vision application of this artificial intelligence is used here. How? The students in the classroom are asked to click a picture of their face, and these are stored on the server. When the teacher enters the classroom, she clicks a photograph of the classroom of all the students of the classroom. A picture of all the students of the classroom are clicked in the picture, and those are matched with the pictures stored on the server. Pictures of the students stored on the server. So it is done within seconds. That part, the attendance part, is done within seconds, and that also eliminates human error and proxies also. It is difficult to do the proxy here and eliminates human error. So basically, it reduces the efforts of the teacher, and she can concentrate more on the academic part rather than concentrating on the administrative part. Then what are proctored exams? Now, why remote proctoring? How does it help? Remote exam management. Candidates can appear for exam from any location, no need to travel to exam center. Now, this is right now not very common nowadays, but yes, in the future, this can be done, this can be inculcated, can be used. This application can be used in online learning. And basically nowadays, as the uh, universities and institutions are asking for students to come and give the exams physically over there, all this can be removed, all this can be eliminated. So remote exam management, candidates can appear for exam from any location, no need to travel through exam center. Eliminate exam center infrastructure. Like schools and colleges are spending a lot of money on creating exam centers, on the infrastructure. That money, effort, time can be saved. Save huge cost of exam management, simple and flexible to implement with huge saving of overall examination management process. So how it is done? Remote candidate logs in for the online exam using secured browser. Remote user shows his identity card and system, and also captures photo of the user. So basically the system captures the photo of the identity card shown by the candidate, and he will show his own face also. Proctor sitting at remote location verifies the iCard and the candidate photo and approves if it is valid. Then the system monitors user screen with continuous video, image, audio capturing process. That means if somebody is cheating, if the candidate is trying to cheat using some his phone, his paper or some audio, so the system has the ability to monitor the user and user screen. So the proctor can initiate live chat with the exam candidate. If he finds such kind of cheating, he can initiate live chat with the exam candidate. He can pause, terminate, and resume the exam. So basically, in that case, it has the power to terminate or pause or resume if he finds there is some candidate who's trying to do cheating. Then exam administrator can review streaming live and recording at a later point. All this exam process can be streamed live and also recorded for further audit by the proctor. So this is how. So if you look at the assessment part is also made easier using the face recognition computer vision feature of the artificial intelligence. Then you have NLP. NLP is natural language processing. That means converting text to speech and speech to text. Now, how this feature can be used? Now, there may be some students in the class who are not good at reading. The reading speed could be very slow, but they are auditory learners, so they can learn better when there is some speech they can listen to. Now, for such students, there is a text to speech part. Now, what it does is this application takes in your text from the textbook, converts to speech, and the student can listen to that speech and comprehend much better. So basically, it is easier to comprehend for the students. For such students who find it difficult to read from the textbook, they become more confident, motivated, engaged in learning. Teachers can spend more one-on-one time with students to clarify their doubts. So it saves the time of the teachers as well. Next is speech to text. The opposite of what it was done here. When the text was converted to speech, you could convert the lectures. The lecture of the whatever lecture the teacher is giving in the class, it is difficult for some students to comprehend because she may be faster. So what happens in that case? It converts teacher's live speech to written content in the form of notes, which the students can further refer to for the reading after the classroom. So both text to speech and speech to text can be used. NLP feature can be used in the classroom. Here we come towards the end of the session, and we have a few web links here for further reference. I have listed a few web links here which show AI in education in the present scenario. And if you have any questions, queries regarding this, you are free to ask. Okay, thank you.
Audience, any questions here? So I posted a link for where this session will be posted, the video for. So if you have any questions, you're free to ask now on the chat, as well as ask Miss Namita over WhatsApp or email as is given on the screen. So I think it was pretty clear, and it was good examples were given for the kind of startups who are working in this domain. I will definitely have a look in on those because we actively work in this area.
Okay.
So since no questions are coming, I would like to close it here. Thank you, ma'am, for giving this session. as well as thank you all audience for joining the session today. Wish you all have
Okay.
a good day ahead,
Yeah.
and
Good day.